Math 1314, section IC1, spring 2022, Tyler Junior College. Section 5.5, point slope form, parallel and perpendicular lines. Video 2, parallel lines. In the previous video, we learned about point slope form, which basically said if you have a line that goes through the point x1, y1 and has a slope of m, then you can write the equation as y minus y1 equals m times x minus x1, where the x1 is the first coordinate of the point that you were given. The y1 is the second coordinate of the point that you were given. And of course, m is the slope. The advantage to point slope form is that it can take in any point that you know, not just the y-intercept, and still requires the slope. If we want slope-intercept form, then we could just take point slope form, solve it for y. So let's talk about parallel lines. So what exactly makes two lines parallel? What does parallel even mean? I think we all intuitively kind of know what this means. For example, if I draw a couple of lines and I asked you, are they parallel? So here's one line and here's another. Would you say these lines are parallel? Well, the answer is no. Why? Well, there's a couple of ways to think about it. Some people say they don't go in the same direction. Some people say they don't have the same steepness. But most people would say that if you were to continue these lines, they would eventually intersect. And technically speaking, parallel is a property of lines, but you can also extend it to line segments. But I think most people know that if lines are parallel, they do not intersect, so they don't cross. But what does that even mean in terms of what we're talking about? Like if I draw this line and this line, oops, let's draw another one and try to make them parallel. I think that's fairly parallel, not quite. Let's tilt it down some. There we go. Okay, I think these are pretty parallel, not perfectly, but good enough for our purposes. So there's a lot of ways to define parallel. There are two lines that never intersect. There are two lines that have the same steepness, two lines that go in the same direction. If you want to think about them as vectors, don't worry about that. But what does this mean in terms of slope? Because we're talking about slopes and point slope form and all that jazz. Well, recall that slope is a measurement of steepness. So what does that mean if two lines are parallel? Well, since slope is a measurement of steepness and parallel lines have the same steepness, what can you say about the slopes of two parallel lines? Well, I think it's pretty easy to draw a conclusion here. If you have the same steepness and steepness is measured by slope, then you should have the same slope. So here's what we're going to use. Two lines are parallel if either of the following are true. It can only be one or the other. Most of the time it will be this one. The two lines have the same slope. Slope measures steepness. If my lines have the same steepness, then they're parallel to each other. There is one very subtle exception. The two lines both have undefined slopes. Remember, there are types of lines that have undefined slopes, specifically vertical lines. That's a vertical line, its slope is undefined. That's a vertical line, its slope is undefined. They both have undefined slopes, and therefore they are both parallel. So in other words, both vertical. Excuse me, they're both vertical, not both. Well, they are parallel, but since they have undefined slopes, they're both vertical lines. Oops, let's do that. There we go. All right, but most of the time it'll be they have the same slope. So there's two types of questions I can ask you. The first is, are these two lines parallel? And there were supposed to be some examples here. Give me a second to set them up. Determine if the following lines are parallel. The first pair on the left, y equals 2/3 x plus 1, and y equals 3/2 x minus 7. If you see any question in your homework or in this class ever that asks, are these parallel? What it's really asking you is, are the slopes equal? Because we have two different lines, I'm going to represent their slopes using subscripts. Slope 1 and slope 2. Notice that both of these lines are in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. The plus can be a minus because b can be negative. But if you look like that, then your slope is in front of the m. Well, both of these say y equals, and so my slopes are in front of the x's. Excuse me, the slope is in front of the x. So the slope of the first line is 2/3, and the slope of the second line is 3/2. Are they equal? No. They kind of look equal, but they're reciprocals of each other. Since the slopes are not equal, the lines are not parallel. See if I can lose a line break in there. There we go. Since the slopes are not equal, the lines are not parallel. So that was pretty easy because the slopes were there for us to look at. But look at the second pair of equations. Y equals -4/5 x and 8x plus 10y equals 15. Well, the first equation is in slope-intercept form, which means we can pull the slope out of it right away. First slope is -4/5. But notice that the second equation is not in slope-intercept form. Since the second equation is not in slope-intercept form, we solve for y. Why is solving for y a good idea? Because slope-intercept form starts y equals, and if we're in slope-intercept form, then we can pull the slope out right away. So let's take the second equation and solve it for y. We have 8x plus 10y is equal to 15. We can subtract 8x from both sides. That will move the 8x from the left to the right, and when it shows up on the right, it will be negative. And then we can try to divide everything by 10. The left just becomes y, the -8x becomes -8/10 x, and the 15 becomes 15/10 if we divide each half by 10. But remember, we're only looking for the slope. And the slope of the second line is -8/10. Are these slopes equal? Well, actually, yes, because you can reduce -8/10 by 2 to get -4/5. And since the slopes are equal, we'll put a red circle around them. Here's the first slope. That's not a circle. Let's try that again. Here's the first slope. Here's the second slope. And notice they are equal, which means our lines are parallel. So sometimes you have to dig the slope out of the equation if it's not in slope-intercept form. Make it in slope-intercept form by solving for y, so you can pluck the slope from in front of the x. There's a second type of problem that you'll be asked to solve using parallel lines, something like this. Find the equation of the line that contains the point 3, 4 and is parallel to the line, let me put the word is in here, parallel to the line 2x plus 3y equals 12. Well, let's think about that phrase for a second, parallel to this line. If we think about that phrase, from an algebra perspective, the word parallel means has the same slope as. That didn't go off as smoothly as I wanted, but the phrase parallel translates to has the same slope as. Parallel to the line has the same slope as. Well, now, if I can find the slope of this line, it's the slope I want. So we want the equation of the line that contains the point 3, -4, and has this line's slope. The problem is we don't know what this line's slope is yet. Well, that's pretty easy to do. We just did it back here. If you're in standard form, like the 8x plus 10y equals 15, we can extract the slope by simply solving for y. So the first thing we have to do is solve the equation for y to find its slope. Okay, well, that's not too bad. Let's do that. The equation is 2x plus 3y equals 12. I'm going to use this arrow, which in symbolic logic means the word implies, which simply means this equation implies the following equation. If we subtract the 2x from both sides, we get 3y equals -2x plus 12. And this implies if we divide everything by 3, y equals -2/3 x plus 4. I'm kind of cutting out some of the steps, but solving for y should be straightforward from this point. And remember, we solved for y because we were looking for the slope, and by solving for y, it puts it in slope-intercept form. And now we know that the slope is negative 2/3. Now that we know the slope of the desired line is negative 2/3, since the slope of the given line is negative 2/3, then the slope of the desired line is also, or I should say parallel line. It's the one we desire, but it's a parallel line, is also negative 2/3. Use this and 3, negative 4 in point slope form. All right. We're going to go to the next page and set this up. See next page. All right, so let's set this up on the next, which will be the final page. Our slope is negative 2/3, and the point that we want was 3, -4. And so point slope form would start out y minus y1 equals m times x minus x1. We substitute the numbers. y1 is the y coordinate of the point, so it's going to be y minus -4. We'll clean that up in a minute. Our slope is negative 2/3. Oh, goody. And then x minus the x coordinate of the given point, which is 3, so x minus 3. Double negative, we clean that up to make y plus 4 on the left. And while we're at it, why don't we go ahead and distribute the negative 2/3 on the right? Negative 2/3 times x is negative 2/3 x. And on the second half of the distribution, we have negative 2/3 times negative 3, but this is much easier than it seems because negative times negative is positive, the 3's cancel, and we're left with the 2. Now, technically, we had our equation the line before because this problem did not ask for a particular form. So what you see there would be a perfectly acceptable answer, except making the minus minus a plus, if we weren't told what form to put it in. But it's a good habit to convert to slope-intercept form. So let's finish that off. Subtract 4 from both sides to cancel the plus 4 on the left, giving us y on the left side of the equal sign. There's the equal sign on the right side. The negative 2/3 x is just sitting there. Negative 2 and positive 4 is negative 2. Here's our equation in slope-intercept form. Point slope form is here. And so let's go ahead and move this down. Point slope form is there. Slope-intercept form is there. But there's a third form, standard form. Do we want standard form? Well, I'll be honest, when I set up this problem, I should have been explicit in how I want the answer. In the homework, it will either say, write the answer in point slope form, write the answer in slope-intercept form, or write the answer in standard form. But I can tell you right now how to predict which they're going to ask you. In a problem like this, they'll give you the equation of some pre-existing line, which in this case, it was this equation right here. 2x plus 3y equals 12. And notice that that's in standard form. Do not be surprised if a homework question asks you to give your final answer in the same form. So we're going to take this and turn it into standard form. Sorry, folks, I had to pause the video. I had a phone call I had to take, kind of derailed my train of thought, but I remembered saying that we're going to turn this into standard form. And I don't think we've done a whole lot of that. So I want to go through this just a little slow, not real slow, because I know the first video was almost a half an hour. I hate making videos that long. Well, let me rephrase that. I love making videos. I hate knowing that you'll probably have to watch it that long unless you watch it at a faster speed. But if we want to convert this to standard form, remember standard form is ax plus by equals c. Technically, we can convert it into standard form by just moving the x term from the right to the left. But normally standard form has no fractions. So let's fix the two things that are wrong with the current equation in slope-intercept form. And I believe that was the correct equation. Yes, y equals negative 2/3 x minus 2. Let's see if we can put this into standard form by getting all the letters on one side and getting rid of all the fractions. Let's start by moving the x term to the right side. It's already on the right side. Let's move this to the left side. And we can achieve that by just adding 2/3 x to both sides, or at least attempting to add 2/3 x to both sides, because that would give us 2/3 x plus y on the left is equal to negative 2 on the right. And then to get it into standard form with no fractions, that's not technically a requirement for standard form, but let's face it, wouldn't this equation look better without fractions? Absolutely. So how can we get rid of the 2/3? By multiplying both sides by the denominator of 3. And that will give us, let's get rid of standard form on the bottom here. When we distribute the 3 on the left, the 3 times the 2/3 x will cancel the 3's, leaving a 2x. And the second half of the distribution will give us 3 times y, which is 3y. And on the right side, we get negative 2 times 3, which is negative 6. So whether they want the equation in standard form, which is what we have right here, standard form, slope-intercept form, which is the one on the bottom here, or point-slope form, which is the one in the box, any of those three are possibilities for how to end what's the equation of the line. The only thing I want to remind you of is never leave a double negative. You should always turn that into a plus. All right, and that's the end of this video about parallel lines. The third and final video in this section will be about perpendicular lines. I want you to ask yourself, what makes two lines perpendicular?